This section we're dealing with wave refraction. Wave refraction is the apparent bending of the wave as it approaches shore. Now you have to be careful here with these words. Wave refraction is specifically, watch the end of the word here, wave refraction. It's different than wave reflection, which we'll talk about at the end of this video. In wave refraction, we have waves coming in. Now, waves rarely come in with the wave crest parallel to shore or the energy of the wave perpendicular to shore. They usually come in somewhere off of that. Now, remember, we talked about what happens when a wave feels the bottom. And what happens is as a wave moves into shore, the front of the wave begins to feel the bottom and it begins to slow down. The rest of the wave is going to continue to move at the same speed until it enters that shallow water as well. What this means is if you're looking at a wave crest, the part of the wave crest closest to shore is going to slow down, while the wave crest farther from shore travels at the same speed, and it makes it appear as if it's bending. Now, the best way to do this is to actually draw it. So this diagram is in your book, and the wave crests here are drawn in blue, and the energy of the wave is indicated with a red arrow. I will try to use red arrows to indicate energy as much as I can. This becomes important later on when we do orthogonals. So we have this wave crest coming into shore, right there. And what happens is this part of the wave enters shallow water first, because we have to assume that in a general sort of way, this is the shallower part, and it gets deeper as we move away from the beach. So this blue part of the wave, this blue wave crest, right here, enters shallow water first. So it begins to slow down. But this part of the wave over here is still going at the same speed. So in the time it takes for this part of the wave to enter here, this part of the wave is actually sort of bent much farther along. As it enters shallower and shallow water, this part of the wave crest begins to bend towards shore. And that's what we mean by wave refraction. This is why when you're standing at the beach, it always looks like the waves are basically coming in straight on, right here. See how these are all basically straight onto the beach? If you were out in a boat, sitting out here, there's a boat, you could see that the waves were coming in at an angle, but if you're standing here on the beach, it's going to look like they're coming straight in, and this is due to the bending of the waves. Now we have to talk about what does this mean. Well, that sounds like no big deal. So let me draw in real quick the wave crests. And we have wave crests, oddly, coming in almost straight across. There's one, and here's some. So those are approximately right. Orthogonal lines are also called wave rays, and I prefer to draw them in red because it helps you remember that not only are they perpendicular to the wave crest, they also indicate energy. And because of the bending of waves, they don't come in exactly evenly. So to first draw these, first we have to draw in our wave crests, and I'm going to do the best I can here on my little itty-bitty iPad. And you can kind of see, here's one wave crest, and it wraps around. Now, why does it wrap around? As this wave approaches, this wave, let's talk about this one right here again. It's all at about the same depth. Still at about the same depth. But now as it approaches the headlands, which is here, if the water gets shallower over here, in this region, right in here, that water will be shallower than, say, the water over here. So what happens is that this central part of the wave begins to slow down, right about here. Since it's slowing down, this part of the wave, which is in deeper water, begins to move faster, and it begins to bend around this headlands. But let's talk about the energy for a second. Wave energy, for the purposes of breakers and coming into shore, is always going to be perpendicular to the wave crest. So to draw a wave ray, you want to find your wave crest and make a perpendicular line. Oh, that's not it. Red. We get a nice perpendicular line right here, and we'll draw it straight in. This wave ray begins to curve straight, 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 but because of the bending of the wave, to make it straight, it begins to hook in. That happens here. And you notice that the energy is centered on the headlands. And what that means is it's going to erode more. Why is it going to erode? Because the energy of the waves is focused on this point right here. In a bay, we have the same thing. We have the same wave coming in, but now, to keep it parallel, we have here we have three. Let's say we have three here. Here we have two. Three waves crashing on a much smaller area as opposed to a much larger area for two, which is why you get erosion at different rates in bays. Generally, and when you're dealing with headlands, you get a lot more erosion than when you're dealing in a bay. So that sort of begs the question, why, when there's a storm, like there was a year ago, do we run and hide the boat up in a bay? Well, waves are still coming in, but the wave's energy is spread out over a larger area, so it's a safer place to hide in a storm. So this one I'm going to do quickly for you, but I'm going to project it tomorrow and you guys are going to practice drawing it. The first thing to do in one of these is to draw your wave crest. And I don't know if you guys can tell, but our waves are kind of coming in like at this angle. And you can see, I hope you can see this in the picture. If you can't, don't agonize over it because we're going to draw them when we get to class. So I'm actually going to draw them here. It's coming in here. And we're kind of going to draw. Now, if you notice, it begins to bend towards the headlands. And we get even better bending and bending. And things are getting a little wonky in there. Now you have to draw in your wave rays or your orthogonals. It's easiest to do in the bays. So we're going to draw a perpendicular line and make it perpendicular here. And we get some bending. Perpendicular here, keep it perpendicular there, spread out. Let's draw this. Let me put my wave crest in a little better. These bend this way. And on the example oh, let me put the last wave crest in. I will try very hard to make sure you have a really good example of this. And you can draw, that's pretty much straight on. Straight on. Begins to get a little wonky here. And so on. And drawing the wave rays is going to be something that you need to be able to show me and explain why there's erosion. Hopefully you can see that this area is going to erode more quickly, and this area, see how the energy spread out, will erode more slowly. This picture is in your book of wave refraction. It's probably the most perfect picture of wave refraction I've ever seen. I really like it. I'll probably try to make my own diagram of it. So you can see how the waves are focusing their energy on the headlands and then spreading them out over the bay. It's a pretty good example. Also, because these waves are now moving in with less energy, the sediment is carried by energy in the wave. If you have less energy over an area, it's going to drop the sediment, which is why bays eventually fill in over time. This is wave reflection. Okay, so wave reflection is a little different. Reflection. It's just like reflection you learned in physics, where the wave is bouncing back. And this diagram is in the book, and this is talking about a very specific point in Newport Harbor in California, where they boogie board. And I wish they drew this in red, but you can see the energy of the wave coming in, and it comes in and bounces back. And because we now have waves coming in this way, and waves coming in this way, two sets of waves are meeting. Well, what do we get when we have two sets of waves? Especially since they're going to have almost the exact same period and wavelength, you can get constructive interference. And that's actually what happens in Newport Harbor in California. They get some incredibly dangerous plunging breakers that break right on the beach, that it can have very, very large wave height relative to the seas around them, because they can get these weird reflected construction interference. That's where we're actually going to leave off on this video, so we'll do standing waves later on.